Hey kiddos! I had to download a new app. Wow, that's kind of cool. So that I can write on PDFs because for some reason my pen still will not allow me to write on PDFs. So I'm just making it work. Good news. That's funny. The good news is that lesson 2 for Module 5 is really a continuation of what we worked on today in class. We are going to continue exploring volume. I really like this lesson because we're actually going to be cutting out these shapes in class tomorrow, and then we're going to be folding them, and we're going to be making cubes. Our cubes are going to have different dimensions. And then we're going to be thinking about, how many cubes does it take to pack these shapes or these figures full, completely to the brim. So I'm obviously not going to be cutting these out in the video, but I just want to give you guys a preview as to what we are doing. So you're going to cut and fold 3 boxes. As you can see, the dimensions for each box are a little bit different. That shaded area is the base. This is sort of similar to the shaded area that we started with today in small group. And then, yeah, we'll just go from there. It'll be kind of cool. But let's go ahead and look at this problem. Let's look at number 2, where we need to predict how many centimeter cubes will fit in each box. Briefly explain your predictions. Use cubes to find the actual volume. This is not to scale. So each of these boxes are a centimeter cube, or each of these cubes is equal to a centimeter cube, the type of centimeter cube that we were using in class today. In class today, we were talking about different ways that we can find the volume of a figure, and sometimes the figures are pretty simple like this one, and as we move through this module, the figures will become more complicated. So what I would like to do is, what happened to my, can I still write here? Wow, this is actually kind of cool. We need to figure out how many cubes it will take to fill this box, or figure out what the volume of this is. Let's go ahead and slice this in half. So we have kind of our front portion here, and then we have a back portion. We can't see the full back portion, but this entire top is shaded in, which is telling us that this entire first story is completely level, meaning it's completely filled in with cubes. So if we split this down the center, if we look at this cube, so that's 1, and then we have another cube here, and we have another cube here, 1, we have another cube here. You guys can see, because the top is completely shaded in, that the exact same thing is happening behind this front row, or behind this front wall. Although we cannot see those cubes, we know that that's what's going on because the top here is completely level. So if we have 4 in the front row, then we know we're going to have 4 in the back row. So we're going to predict 4 plus 4 is equal to 8. Tomorrow in class, we're actually going to be creating these shapes with paper, and then we will be able to. Oh, that's so funny! This is a new app, so within Google Chrome. So sorry that number is looking goofy. Okay, funny. I guess that'll come back in a second. Okay, so our prediction is that this figure has a volume of 8 centimeters cubed. Let's see what happens here. Oh, this is funny. Okay, it's going to take some getting used to, but we're just going to make it work. Great. And remember, we're looking at centimeters cubed because this is 3-dimensional space, you guys. We're actually using real life cubes. That's where the 3 or the cubed comes from. Here we're going to continue right now and in class tomorrow, making a prediction and then figuring out the actual volume, or actually how many cubes it takes to fill in these figures. We can look at this a few different ways. We can look at this as first floor, second floor, or we can take a look at this as front row. We can take this, if we were going to slice this like a loaf of bread, we can take the front row off, and then we'll have the back row. We can also slice this We can make a slice here where we would find 4 cubes, and then we can make a slice here where we will find another 4 cubes. We know that there's another 4 cubes there because our top layer is completely filled in. It's completely level. So then we have another slice that is of 4 cubes and another slice that consists of 4 cubes. So that means we have 1, 2, 3, 4 slices that consist of 4 cubes. 4 times 4 is 16. So we are predicting, and again you will confirm this tomorrow in class, we are predicting that this figure is made up of 16 centimeters cubed. And then let's look at this one too. Let's do this one sort of the same way that we made our buildings in small group. So when we made our buildings today in small group, we started with our first story, and then we made a second story. Of course, this is not the same dimensions as what we were making today in small group, but we're going to use the same process. So let's look at this as far as first floor, which is here, second floor, third floor, and fourth floor. So how many cubes do we have making up the first floor? Well, it's 1, 2 wide by 1, 2, 3, 4, 5 long. So we're using 5 cubes here and 2 cubes here. So we know let's look at 5 times 2. It's really an array. We know that the first floor is using 10 cubes. So we've got 5 wide and 2 deep, so 5 times 2 is 10. So the first floor is using 10 cubes. The second floor is using 10 cubes because, again, this is all level space. We know that these are all evenly stacked upon one another. So we have 10 cubes here. We have 10 cubes here, 10 and 10. So we have 4 sets of 10, which is equal to 40. Our prediction for this figure is 40 centimeters cubed. The volume that we are predicting for this building is 40 centimeters cubed. Again, tomorrow in class we will confirm that. This is more cutting, more cutting. Okay, cool. You guys are getting, that's all you're getting for tonight. We are going to have tons of fun tomorrow continuing our exploration of volume. I thank you in advance for your patience with the sloppiness. I'm so sorry about it, you guys. We're going to get this figured out. I hope my pen isn't broken forever. And I really just want you guys to be aware of the fact that we can look at these figures in a variety of ways. And my goal is for you actually to look at these figures in a variety of ways. We're going to make predictions tomorrow as far as volumes for these figures, and then we're actually going to find the volume by constructing the figures out of paper and placing cubic centimeters inside them. So it's here comes Cal. It's going to be great. Can't wait, and we'll see you guys tomorrow.